So for those of you who are new here, and as a reminder to those who aren't, CSTEM is a nonprofit student-led STEM outreach organization. We aim to connect the classroom curriculum to real-life careers by introducing you to the various professions in the STEM field. We hope to encourage many or all of you to pursue careers in STEM.
So during the seminar, we have invited two very accomplished professionals in engineering in different fields of engineering, and we'll start with a short presentation for each of them and continue with a Q&A. Through the presentation, we hope you learn more about their job responsibilities, their educational backgrounds, and they may give you useful advice you may take on your pursuit of similar STEM careers. If you missed the seminar or part of it, it will be recorded and available on our YouTube channel, which we will link. So stay tuned for the update on our Instagram or fill out the link in the chat to join our mailing list.
Our first guest speaker is Miss Katie Schneider. Katie Schneider has a Bachelor's of Science in Engineering Physics and a Master's of Science in Mechanical Engineering from Colorado School of Mines. Ms. Schneider has worked as a patent engineer at Holland & Hart since 2020, where she drafts figures and descriptions for patent applications and prepares arguments to the U.S. Patent and Trademark Office. Ms. Schneider will start law school at the University of New Hampshire Franklin Pierce School of Law, where she plans to study intellectual property and patent law. Outside of her work, Ms. Schneider loves reading romantic comedies, shopping for new clothes, watching Formula One, and playing with her cat, Monsa. Let us welcome Ms. Schneider.
Thank you guys so much for having me and for that nice introduction. I'll go ahead and start to share. All right. So I'm going to ask you guys a few questions as we go. Feel free. I know not a lot of you have your video on, totally fine, but feel free to just jump in. Hopefully get you guys involved a little bit today. So today I'm going to talk about my job as a patent engineer, tell you a little bit about what patent law is about and what that even entails. And really the theme of my presentation is about enjoying what you do and finding something in the STEM world that you're really excited about and that you enjoy doing every day. So in addition to that, I'm going to talk a little bit about the skills I've learned at my different roles and really go through my career path from college until now. I would describe it as very non-traditional in terms of what you would envision an engineer doing. And I kind of took a lot of twists and turns, and I want to encourage you all to do that as well. And then I have a few tips that I have carried with me through my career as well. And again, I'm sure many of you, are at different stages in high school, middle school. Maybe some of you already have an idea of what you'd like to do someday. So all of this, what I'm going to talk about today can really be considered as you choose where you want to go to school, what classes you want to take, what internships you'd like, anything like that. I hope you can find some application. So as was mentioned, I have a bachelor's in engineering physics, which is really applied physics, and then a master's in mechanical engineering with a specialization in thermal fluid systems, which was kind of a fancy way of saying more physics. It had a lot to do with aircraft aerodynamics, fluid dynamics, and things like that. One thing I want to mention is a lot of colleges these days have kind of 5-year master's programs, they're called. So I only had to do 1 extra year of school to get my master's. I started to take classes during my undergrad, which was a really great way to get both those degrees. It was non-thesis, and I think it gave me a very well-rounded education for what I wanted to do. So I highly encourage you guys to look into programs like that. I also want to mention just a couple of things I did on campus. I loved my extracurricular activities. I was involved in the Society of Women Engineers and similar organizations for STEM majors, and then a few project teams as well. I also was a teaching assistant and a tutor for physics through pretty much my whole time at Mines. And that was a great experience. It really taught me how to mentor, to lead, to teach, which I do in my current job. So just a little bit of a background there. And as I go through, I'm going to talk a little bit about the different jobs and internships I've had and explain kind of why I made decisions and why my path took so many turns that I wasn't expecting. Going into college, I really thought I wanted to be an aerospace engineer, work for NASA, maybe do something with aircraft or spacecraft. And I didn't necessarily lose that, but it looks a lot different than I thought. So early on in college, I had an internship at Los Alamos National Laboratories. It was a very heavy research job. I worked in a lab. I did a lot of programming and coding. It was about particle physics research, which was so fascinating and a great experience to learn how to handle high-tech equipment and, again, do programming. But it wasn't, I just didn't enjoy the day-to-day. Being in a lab, I wasn't sure what to expect. I didn't really understand what engineers did all day or what scientists did all day. So once I got into the lab, I kind of realized it was a little too slow paced for me. It was very solo work, things like that I wasn't exactly thinking about. I loved the physics, but the day-to-day work wasn't exactly what I wanted to do. So after that, I worked at Sierra Nevada Corporation as a systems engineer for a few years and worked in a few different groups. How many of you heard of the term systems engineering? And feel free to shout it out if you know kind of what that is, or could you give me a definition for it? All right, well, this will be fun then. So systems engineering has become a really common job you'll find for a lot of different companies, especially in the aerospace world. So the idea is really that you're kind of a mechanical engineer, you're electrical, you're doing all these different systems, and you're really in charge of the system as a whole. So instead of working on, for example, just the electronics of an aircraft, your job is to make sure the electronics and the mechanical and all the safety features and the flying features, all of that works together in one. So it's a very high level view of a system. I think it lends very well to physics majors and physics minds because you kind of have to have a worldview of things. So Sierra Nevada Corporation is a company that they're an aerospace defense firm, and they focus on modifications to different aircraft. So while I was there, I worked on primarily communication systems, headphones and things like that. But again, it was, how does our headphone work with the flight control system? Is there a way we can merge these systems and make it a really big, make this whole aircraft very integrated? At SNC, I also got a lot of responsibilities in terms of writing deliverables and meeting with our clients and actually presenting our work. It was really fun for me to write about the designs I was doing. So for example, I would have a diagram of a system I designed, and then I'd have a document that went along with it that explained what it did, how it worked, almost like an instruction manual. And I really enjoyed the opportunity to write. In high school and especially in college, I always joked that I was the student who liked to write the lab report, but I never wanted to do the lab. Like, I would let my partner do the experiment and I would write the paper. So this particular role lended really well to that because I was able to write a lot and explain what I was doing to our clients. I also had an opportunity to work at Sierra Space, which is under the company, and it's their space division. And I worked on NASA's Artemis mission, which I'm sure you guys are all familiar with. SNC had a few different portions that they were working on. So I got to work on that a little bit. It was very cool to be in meetings with NASA. Like, it was what I'd always wanted to do, and that was very exciting. So again, I really enjoyed this job. I was there for almost 4 years, but I also just didn't feel completely fulfilled. I didn't love how long the projects were. We'd be on the same contract for 3 to 5 years. It was very drawn out. Because it was a defense firm, there was a lot of government involvement. So a lot of that moved slower. It was a great experience, but it still wasn't quite what I wanted to do. But I really clung on to this idea of loving the writing that I did. I discovered that I kind of learned the term science communication at this time and realized that I enjoyed talking about science more than doing it, especially with my physics background. Nobody in my family has a STEM degree. So I would come home for Christmas or Thanksgiving and just tell my parents about physics. And it was so much fun for me to be able to explain it in a way that people understood. And I really kind of clung on to that as I went through school. So today I work in patent law. How many of you have heard of patent engineering, a patent agent, patent attorney, as a possible job for you guys? Has anybody heard of that? A little bit. Do you guys know what they do? Any guesses?
Do they write the patents that are sent to like the trademark office?
That's exactly it. So I hadn't heard of this job until I was in grad school and trying to decide what to do. I kind of had a moment of panic where I just didn't know. And I stumbled across patent law as sort of a non-traditional engineering career. So I had done this research work. I had done the aerospace job, which, especially in Colorado, is a very common path for a lot of students to take. There are really great jobs, a ton of companies out here. But again, I was very nervous about pursuing that path without being sure it's what I wanted to do. So I stumbled upon patent law, and I'm going to give you a little bit of an overview of what patents are, what patent law looks like, just to get a better idea of what my day-to-day job is like. So here's a patent over here. I know it's not very big and you can't probably read it too well, but really a patent is rights to an invention, which could be either a product, so a mechanical device or something like that, or a process, what that mechanical device does. And it has to be new, obviously it has to be novel, and it has to solve a problem. So for example, you could patent a chair as a chair. You know, the first chair that ever existed is probably patented. So it would be a device that you can sit on that can do some other things maybe, or you can patent the functionality of a chair. So say you have like a desk chair, you could patent the fact that it can rise up and down, or that it has wheels that it can move on, things like that. It's a very basic example, but those types of patents exist today. But you can't patent something that doesn't solve a problem. So if we didn't need a desk chair, if we didn't need to raise up and down, you know, today that's very handy. You can change your desk height, you can change your chair height, whatever. But if you didn't need to do that, it couldn't be patented. So I think a very fun fact about patents, it was, I believe, the third amendment to the Constitution. It was written by Thomas Jefferson. So patents have been in the US Constitution pretty much since the beginning of our country, which I think is very interesting. So the general patent process, which you were referring to, is you file a patent. So we meet with inventors, we learn about their technology, and then we actually write the patent. We send it to the US Patent and Trademark Office. They review it, and they're going to issue what's called an office action. And that's basically a rejection of your patent. So they're going to say, well, it's not new enough, or somebody already does it, or, you know, there's numerous ways they can reject it. Then it's our job to do research and figure out, well, is this really new? What's already out there? We want to get our client, obviously we want them to get their patent. So we write an argument back that says, you know what, here's why it's different. Here's why we believe it should be granted patent. And then from there, the USPTO will either say, yep, we agree, here's your patent, or maybe you'll abandon it if you don't want to continue the process. But this back and forth with the USPTO goes on many times, and it can go, it can be several years long of a process, really depends on what your client wants. But this is the real meat of what we do. And it's a very fun, research-heavy job, and I'll get into that a little bit more. So what I do currently as a patent engineer for Holland & Hart is, as was mentioned, I draft the patents themselves. So you have kind of a collection of figures that describe your product or your process, and then descriptions to go along with those. And the goal is that your patent can describe whatever your invention is well enough that somebody familiar with that area could do your patent or build your device. So it doesn't need to be a layman's person who understands it, but say you're patenting a specific medical device. A doctor in that field would have to be able to use your device based on how you describe it in your patent. The other kind of half of my job is again, writing these responses to the USPTO. So it's a lot of research that goes into explaining why your invention is different from one that's already out there. I think a lot of people think about patents and think that it's something very new. You know, they're definitely new, but something like groundbreaking, like you're patenting a new medicine, or you're patenting an iPhone, like something like that. And while those things exist, and there are some very remarkable patents, most of them are very small distinctions. So Apple, for example, maybe they have many patents on iPhones, but then they'll have an individual patent on each button on the phone, or the volume button, or different things like that. So they're very nuanced, small changes. And it takes a lot of research for us to go in and figure out how those mini changes are different from things that already exist. So very research heavy. And then my favorite part of the job is really working with the inventors. So it's a really fun way of bridging kind of the legal worlds with our attorneys, with these very technology focused inventors, and talking to them about their ideas and making sure they can actually get a patent off of it. So just to clear up some confusion, I think some people, there's so many different terms that get thrown around, and I just want to quickly cover the difference between a patent engineer, patent agent, and patent attorney. And this is a very exciting thing, especially if it's a role you're interested in. There's a lot of opportunity for career growth and development as you go as a practitioner. So all of these three have kind of what's before it. So all of these three roles, you have to have a STEM background. In order to practice patent law, you actually have to have a STEM degree, which I think is really fascinating. So somebody can't just come from law school and become a patent attorney. They have to have an engineering degree first. We all kind of do the roles I mentioned in the previous slide. Then you can become a patent agent, where you're registered with the USPTO. You take what's called the patent bar. So it's the only legal practice area that has their own bar exam. So you can actually take the patent bar without being an attorney, and then you're licensed to work with the USPTO. You still can't go to court. You can't do patent litigation, which would be like patent infringement. But you can write and interface directly with the USPTO. And then a patent attorney has all of this, and then of course a law degree, and they're licensed to practice. So as I mentioned, really great career growth. There's so much you can do with your patent agent certification, but then if you get a law degree on top of that, you can get into licensing, how patents are used, how people make money off of their patents, things like that. So yeah, a lot of opportunity for growth there. So I think patent law is a very interesting opportunity because it's non-traditional. Many of my friends at Mines, which was a purely engineering school, we didn't have any other majors. It was a lot of people just didn't want a traditional job. They didn't see themselves in a lab like I did. They didn't want to pursue PhDs and things like that. And I think patent law is a really great way to stay grounded in technology and STEM, and you're surrounded by these next gen ideas, but you're not actually working on them yourself, which is kind of fun. It's like, it goes back to the lab thing. Like, I loved writing lab reports, I love learning, but I did not like putting electronics together and making the light bulb light up. Like, that just wasn't what I like to do. It's a ton of writing. Writing a patent, they could be anywhere from 20 to 500 pages. So it's a ton of writing, a ton of researching, as I mentioned. You're reading patents all day long. It's very heavy that way. But if you like reading technical things, again, it's very interesting because you're learning the newest things that are out there. It's also very fast-paced, and I know that word is commonly used, when you look at job descriptions. It's a fast-paced environment. I don't mean that so much as I mean you're always doing different things. I have probably 25 patents on my assignment sheet right now. So I can kind of switch it up and do different ones at different times, instead of when I was at the research firm and at Sierra Nevada Corporation, my projects were scheduled for years at a time. So I really enjoy context switching, and like I mentioned, always learning. I also think it's really fun to kind of have one foot in the STEM, legal, and business worlds. It's a really cool bridge of, making sure all these things integrate together. And it takes a special person to have the right mindset and the right personality to be able to work with them. I'm sure you guys, some of your STEM teachers or some of your professors maybe you've had are your classic, nerdy scientist, which is what I am at heart. So to go from working with people like that to working with lawyers, it's a really big change. And it's kind of fun to figure out the nuances of that. So I guess kind of in all of this, I just want to point to the fact that, again, I took kind of a non-traditional path. I was very set on track to work for an aerospace company, do something with aircraft or with satellites or space or something like that. And I always thought that's what I wanted to do. And every decision I made in school was kind of targeted toward that. Like, I wanted to get a master's degree in mechanical engineering, so I wasn't pigeonholed into theoretical physics. I wanted a more applied degree. I chose to work at the aerospace companies in Los Alamos because I knew they were very focused in what I liked. And getting to them and realizing it wasn't the right fit, that's okay. I could have stayed there and made really good money. I had great friends. I loved my coworkers, and it was what I thought I wanted to do and what my family expected me to do and what my professors had taught me to do. But I knew I didn't want to do it. And it was really hard to make the decision to switch to patent law because it's such a big shift. And a lot of people were very confused. They didn't understand why after 2 STEM degrees, I would want to go to law school. It didn't make sense to a lot of people, but to me, it made sense. And I just want to encourage all of you to do the same as you're moving through your degrees. You don't have to take a job just because you think it's what's expected. I think it's really important to be happy with what you're doing, and I think it's possible. It truly is possible to enjoy your work. I'll finish that discussion in a second, but kind of in that vein of how I switched and what I realized I liked and didn't like about my different jobs, here's some different skills I used. And I think it's useful to see the differences and also similarities between these 2 major roles. So again, the patent side and then the engineering aerospace side. So communication is critical to both. And you're going to hear this time and time again through school. Every teacher, every professor, every boss or mentor you have is going to tell you how important communication is, especially for engineers. We like math, we like equations. We don't love writing most of the time. Some of us do, but it's not common. So it's really important as you're going through school to take advantage of your communication classes to learn how to write well, especially with ChatGPT and all of these things coming out. It's going to be very clear who are good writers and who are not. So again, I encourage you to really take advantage of that. More than writing, it was communicating with clients, leading meetings, giving presentations. So presentation skills and public speaking is very important as well. In a traditional engineering job, I did a lot more programming, drafting, simulations, using software on my computer. I didn't enjoy any of that. Programming was very challenging for me. I've never been good at it. I've never enjoyed it. So that was a pretty big red flag for me at those roles, that it wasn't what I wanted to do. On the other hand, patent engineering, again, you're not as hands-on doing the science, but you are doing a lot of research. So it's a lot of Googling older patents, Googling companies, going as deep as you can in a company's website and trying to find out how they built what they built, things like that. And again, it's cutting edge technology. So a lot of the times, if you try to Google something, there's nothing on it because it doesn't exist yet because it just got invented. So it's a lot of critical thinking and trying to figure out yourself how something works or why it works the way it does, which in its own way is kind of engineering without the hands-on aspect. In patent law, you're dealing with law, so you have to learn. You definitely don't need a law degree to do what I do, and to write patents, but you'd have to understand the implications, legal implications of certain things you do. You have to understand, why certain things are patentable over than others. On the systems engineering side, it was a lot of understanding governmental policies. So, for aircraft, we had to work with the FFA or FAA all of the time. Things like that, that are very regulatory and a lot of rules you have to follow, but it's a little bit different. Patent engineering, again, is very critical thinking, figuring out how things differ, how they're the same, being able to articulate a very complicated invention in layman's terms. As an example, I work on a lot of patents that are related to cell phone communication technology. So how your phone operates with like a tower, how 5G works, things like that. And a lot of that is very in the weeds, and it's not common, language that we use every day. So it's kind of figuring out a way to combine like very technical writing with legal writing. Systems engineering, on the other hand, was very big picture thinking. So you're not in the weeds like you are for writing a patent. You don't need to know the specifics. You have to understand how everything fits together for one system. Similar vein, patent engineering is very meticulous attention to detail in terms of the legal things. There's just a huge case at the Supreme Court where somebody lost a patent infringement case over the word a, like a singular thing. That dictated the entire lawsuit. So very, very attention to detail. If you like that, If you don't like that, systems engineering, again, you have to be detail oriented, but it's much more troubleshooting. It's much more, again, big picture thinking. How is this going to affect the whole system rather than kind of one small detail? So, from my experience, they're very different. And also my skills from my systems engineering really have carried on and helped me as a pattern practitioner. So just a couple tips, things that I've learned that I would encourage you all to do and carry on. As I've mentioned, really listen to yourself and do what you want to do. I have on here as well, work to live. I believe very firmly in work to live, not live to work. So you should enjoy what you do, but don't make it your whole life. Don't make it your whole identity. And I really think that's possible. I think especially with COVID and how kind of our workforce has changed with working from home being a possibility and things like that, I think it's really possible to find something you like to do and not dread going to work every day. You're going to have jobs that you don't like, and that's good to know and that's good to experience. But I do hope for all of you that you find something you're really passionate about. I never thought I would care about patents, but I could talk to you for the next 5 hours about them. I love it, and I think it's really fun. I can't wait to go to law school. So I hope all of you find that, and don't be, I would say that don't select a job or don't choose a college because you think it's the best one, because you think it's what's expected of you, because you think you'll make the most money. Those are important things, but I don't think they should be your main criteria. Again, if you make all the money in the world, but you don't like your job, you're still not going to be happy. So, kind of the same vein, find what you want to do. I also would say, say yes to as many opportunities as you can without overcommitting yourself. So kind of two elements of this. In terms of saying yes to things, if you have an opportunity to do an internship and you're not sure if you'll like it, go for it. You might love it, you might hate it, but at least either way. Like I said, some of the jobs I had, they were good opportunities, or they were good experiences because I learned I didn't want to do them long term. So say yes to different things without overcommitting. Don't join every club. Don't join every group you can just to put it on your resume or just to say you did it. You want to invest in things you really actually care about. I was on some, as I mentioned, competition teams in college that won international competitions, but I put 20 hours a week into them sometimes. And I couldn't have done that if I had done, 10 different clubs. So don't spread yourself too thin. It's way better to really commit and really be involved in a couple things than to just do an hour a week at 10 different things. And then kind of along with that, thoroughly enjoy your hobbies. You want to find things that fulfill your life outside of work as much as I want you to enjoy your work. Find things that really supplement it as well. I play volleyball on the side, as was mentioned. I love to read. I love, certain sports, and all of that gives me a good balance so that I can show up on Monday and do my job and enjoy it and take breaks when I need to. So I think balance is very important, but find things you love because life is really short and it's not all about work. I think that's all I have. I would love some questions. Here's my contact information, so feel free to reach out if you'd like to talk offline as well. But thanks for having me.
Thank you, Ms. Schneider, for that really great presentation. I think that really covered a lot of things, especially about patent engineering, because I definitely would not have known the distinctions between like patent law, patent engineering, and patent attorneys. And so I think we're going to have a few minutes for question and answer. So I see the first question in the chat is, how long does it usually take to get a STEM degree?
That's a great question. So I think a typical bachelor's degree is 4 years. I did mine in 4 years, but I also had many friends who did them in 3.5. So I think, you could come in with credits and maybe get a little bit ahead, but traditional is 4 years. And then if you'd like to get a master's or a PhD, a thesis master's where you do a research project or something like that could take, 2 to 3 years. As I mentioned, I did a non-thesis, so I just took classes from my master's, and it was only 1 extra year. So I did undergrad and master's in 5 years total. And then a PhD really ranges. I think it kind of depends on where you go and what your research is, but it's going to be at least several years. That answers. I think I see another one in there. How did you discover patent engineering? That's a great question too. So I kind of two ways. I had a presentation in one of my classes senior year of college. And it was our college had kind of their own legal department that actually handled patents and other aspects of intellectual property for the university. So for example, if a student came up with something in class, that this department would handle whether the student owned it, whether the university owned that idea, things like that. So we had a presentation from that department, and it wasn't about patent law as much as it was about how to do research, and kind of how to properly give ownership of research when you're doing a master's or a PhD. And it's kind of a different topic. But anyway, I had heard about it there, but I never realized it could be a career for me. I thought it was much more legal than engineering. So I actually just Googled, like, again, I was kind of in a frantic state, didn't know what I wanted to do yet when I graduated. So I Googled non-traditional engineering jobs. And I think patent law was number one on several lists I looked at. Science journalism was up there too. So kind of writing articles or doing like a podcast about science. And then third was, which I thought sounded very fun, was like a set designer for movies, but it had to do with like the pyrotechnics and like the building of the sets from like an engineering perspective. And then the fourth one, which I actually had a couple friends do, was lighting design for concerts. So very random, right? Like you wouldn't ever hear of those. But for some reason, patent engineering just really stuck with me, and I pursued it from there, and reached out to a few people through professors and started to talk to some people about it. But it was very serendipitous. I think I'm very lucky that I stumbled upon it when I did.
So one question I actually had is, what do you do to kind of decide if a product is novel or not? I've done like a few science fair projects, and I know Delia has as well. And usually I think we kind of just look at like papers that have been published about a certain topic, but for something to be novel, does it mean that it hasn't been patented before or it hasn't been talked about before? Like what's kind of the criteria for something that's new?
Yeah, that's such a fun question for me to answer. So it kind of depends on what it is. But I'd say most of the time, it doesn't have to be patented for it to be considered as existing knowledge. So it just has to be publicly disclosed in some way. And then if you do the same thing, it's not new. So say you read an article that wasn't a patent, but you just, like you said, you read a research paper or an article about something, that would disqualify the same idea from being new. But if you built on that and added to it, that could be new. So I've had, in terms of the office action rejections that the USPTO says you can't patent this, I've had like books cited against me before, like not even patents, but they've said this idea of this device was in this fantasy book, so you can't patent it because it was before your date. So it's actually really kind of interesting in that way. I will say though, if you guys have ideas, I think it's easier to get a patent than a lot of people think. It's actually very affordable, especially if you're doing it on your own and not with a company. And it's pretty easy to show distinctions, especially if it's an advantage. So like you said, if you're doing a science fair project on, improving something or testing what's better for this or that, whatever it is. If you can show that one, you have an improvement, and two, that nobody's done it before, you're good. And that doesn't mean you have to scour the internet and try to find every single instance of your research. You just have to prove within what the examiner could also Google that your thing is new. So, a whole different topic. If any of you are interested in or have ideas, I'm happy to talk to you about them. It's also very cool that you don't have to be 18. Basically, you don't have to be an adult to have a patent. So you can have a patent as a child, which is really cool, I think. So yeah, I hope that answered your question.
Yeah, it definitely did. Thank you so much.
I think I have one last question to round this off, but would it be possible to be a patent engineer in and from like any STEM degree, science included, or is it mostly engineers who become patent engineers?
That's a really great question. So there's actually a list online and it's pretty extensive, but it really pretty much covers every single science degree and engineering degree. The only thing that's a little bit difficult is math, like pure mathematics. But if you prove you've taken a certain number of engineering classes within your mathematics degree, you can still qualify. So it really is any STEM, which is really cool. Even medical degrees count. So it's pretty cool. But again, it's neat that it's an elite group. Like not everybody can do patent law, which I think is kind of cool. So.
All right, so I think that will be our final question. So thank you so much for answering all those questions and for that really wonderful presentation.
Yeah, thank you guys again for having me and don't hesitate to reach out.
Yeah, so once again, thank you so much, Ms. Schneider. It was really interesting to learn about patent engineering, and it's definitely something that I didn't really ever think about pursuing as someone who's interested in STEM, so that was really great to learn about. So our next guest speaker will be Mr. Eric Hilden. Mr. Hilden received a Bachelor of Science in Mechanical Engineering from the University of Wisconsin-Platteville. In 2013, he began working for Georgia Pacific, a world leader in making tissue, pulp, packaging, and building products. Mr. Hilden has over 10 years of experience in project engineering for Georgia Pacific. Currently, he manages capital projects for the company's mill in Green Bay. So let us welcome Mr. Hilden.
Well, good afternoon, everybody. Thank you so much for this opportunity to talk to you today. I'm excited to be here and excited to share a little bit about my journey with you all today in mechanical engineering. And I hope it encourages and inspires some of you to potentially pursue a career in a STEM related field. So with that, let me share my screen here. Okay, so a few things that I wanted to discuss with you all today. I want to talk a little bit about what my educational background is, what my professional experience has been over the past 10 years, what my current job responsibilities are, some of the things I do on a day in and day out basis, some of the favorite things about my job, and then I wanted to touch on some of the benefits of STEM education, potential career paths that you could take, and then some advice that I would have for students that are looking to follow this path. Um, so with that, we'll just jump right into my educational background. So I earned a bachelor's degree in mechanical engineering with a minor in math from the University of Wisconsin-Platteville back in 2013. And you might be wondering, so why did I choose mechanical engineering in the first place? And I decided on that field because it's something I've always been curious about how things worked, how I could make them better. I always liked tinkering with things, taking things apart. Growing up, one of my favorite toys was Legos, and I just love building with them and seeing what I could design and create with them. And I ended up spending countless hours playing with them when I was little. And then later on, when I was older in high school and in college, I really enjoyed working on cars. And so that got me really interested in it as well. The first car that I bought, I modified it. I made it faster. I took it drag racing. And I really enjoyed that. I enjoyed seeing how I could improve it, make it better. That was all very interesting to me. So I've always been very hands-on, a visual learner as well. So for me, actually being able to see how things work mechanically, that really interested me. And I've also been pretty good at math and science. I'm a very detail oriented as well. So it was just a pretty natural fit for me to go into mechanical engineering. So I'll touch a bit here on my professional experience. I would say to this point, my career path, it's been fairly linear. I did, I started college. I went there for a couple of years, and then I ended up doing a co-op with the train company from May 2009 until January 2010. And for those of you that aren't familiar with the train company, they manufacture HVAC equipment. So that was a really interesting for me to go and work for them for a period of time. And I supported senior engineers by collecting and analyzing technical data and just generally supporting them in their roles. Um, and then I went back to school for about a year, and I actually had another opportunity that really interested me, and I went and did another co-op with Harley Davidson. So that was actually located in Tomahawk, Wisconsin, and again, another really interesting experience for me personally. In the plant that I worked at, manufactures the plastic and fiberglass parts for the motorcycles. So that includes things like the sidecars, the saddlebags, the windshields. They do painting and striping there as well for the motorcycles. So I had the opportunity to provide engineering support on a daily basis in the masking, striping, and graphics areas. So that was really neat. I really enjoyed that. And then I ended up going back to school to finish getting my degree in mechanical engineering, and that was in 2013 when I graduated. And then I got hired right out of college by Georgia Pacific in Green Bay, Wisconsin. And my current role is a project engineer and a project manager for the mill. And as Annika mentioned in the introduction, Georgia Pacific, they're one of the world's leading makers of tissue, pulp, packaging, and building products. And the paper mill that I work at in Green Bay, it's actually one of the largest waste paper recycling operations and tissue producers in the entire world. We produce commercial and retail brands of paper products such as paper towels, napkins, towels. So I'm sure you've utilized our products and likely use them on a daily basis. These are the mill that I work at. We mainly make products that can be found in hotels, restaurants, airports, hospitals, schools, places like that. So, and when I graduated, I really didn't have any exposure to the pulp and paper industry. So for me coming in, there's actually a very surprising amount of technology, science, and engineering that goes into making paper that you might not realize. And I certainly didn't realize it when I graduated. But I think the end product of, say, a napkin or a paper towel, it's a very simple product in the end, but in reality, it's a very complex product to produce, and there's a lot of engineering and technology that goes into that. So for me, it's very neat to be a part of that. So what are my current job responsibilities? Right now, I'm primarily manage capital projects, as Annika mentioned, for the mill in Green Bay. And for most of the projects I've been a part of, I've been the mechanical project engineer and the project manager for each project. So what I will do, I will work with the project team to develop and implement projects. So what we do at our mill is that each year, the mill leadership team will bring forward a capital project plan, and the most important projects are brought forward, and then they're assigned to individual engineers like myself. And these are projects that are essential to keep the mill running at a high level. And they're typically done to help the company reduce costs, improve safety, improve reliability, or simply just to sustain the assets that we currently have, things like that. So, so every year it's a little bit different for me. I'll get assigned to new projects to work on, and I'll be responsible for managing several projects at a time. And one of the things I really enjoy about my job is that I get to develop the projects really from the initial concept all the way through to completion. So I'll be working with a team. It'll typically include folks from the operations world, so manufacturing engineers, designers, other electrical engineers, instrumentation and process control engineers, reliability engineers, and then I'll work with vendors to determine what equipment would be the best fit for the project that we're working on. And I'm also responsible for developing project cost estimates and schedules. And then I will work with contractors to actually install the new equipment. So during this time, a lot of my time gets spent managing the construction to ensure that equipment is installed safely.
Mr. Hilden, I don't know if you're speaking or not, but we're not able to hear you right now.
Oh, sorry about that. I'm not sure what happened there. Can you hear me now?
Yes.
Okay. No, I was just saying the last piece there was mentoring. I've got a good opportunity to work with entry-level engineers and help develop their skills and give them guidance when they get started. And I actually just got started with one that started a couple of weeks ago. And so that's been great, just having them come in and help develop their skills as they get started with their careers. So that's been a pretty fulfilling part of my job. So what are some of the favorite things about my job? I find that for me, it's very neat to be able to see projects go in from start to finish. I find that very fulfilling. I get to see, being here at the mill every single day, I get to see the results and the benefits from the projects that I have managed. And the other thing that I've got there is the mill that I work at it's very large, and there's a lot of opportunities within the mill. So I've had the opportunity to work on a wide variety of projects, and that ranges from the power plant to the paper machines, pulp processing, wastewater treatment. So a number of different areas. And I got a couple of pictures pulled up here from a few of the jobs that I've worked on throughout the years. That top picture there is actually a couple of pumps that we installed. I think that was about 5 years ago. And what those pumps are doing, they're actually, this was before they were fully installed, but those pumps today are actually supplying all of the water for the processes throughout the mill. So they're two very, very critical pumps for the mill. I guess you could say that they're not pumps that people are typically thinking about, but if something were to happen to them, it would be a big deal, and it would actually end up shutting the mill down. So that was one of the projects that I had, was to replace the pumps that we previously had down there. They were old and they were very unreliable. So that was one of my projects, to come in and install new technology, new pumps, and size those correctly for what the mill needed. So that was a pretty fun project to be a part of. And then just kind of speaking to the variety of products that I have here, this picture on the bottom there is actually a clarifier that we repaired. That was, I guess it's been almost 10 years now since we did that. But essentially, the clarifiers, they're large settling tanks out in our wastewater treatment plant, and they're used to remove solids in the water, and they're used to clean up the water before getting sent back out to the river. So as you can see here, just between these two different projects, there's a lot of variety. No two are the same. Another thing that I'll say in my role is that there's a lot of time spent out in the field, and then I guess it's a nice split between the office and the field. So it helps kind of break up the day, and you're typically at different phases of the project at different points of the year. So that's nice. Just every single day is a little bit different. And then the last thing that I've got there is that my responsibilities have grown in the 10 years that I've been with Georgia Pacific. So when I first started, I began managing projects that were around $30,000, and now I'm managing projects that are over $10 million. So for me, that's been a very rewarding and very fulfilling thing to see that progression and be a part of that. So I wanted to touch on some of the benefits of STEM education. And I'm sure, as you all know, that going into a STEM field, it can be, you can bring in a pretty good salary. For this presentation, I just focused on the mechanical engineering. I got some stats for that. And this is from the Bureau of Labor Statistics, right from the government's website, that the mean salary for a mechanical engineer, it's just over $100,000. And so you can do pretty well. And then the top 10% earn close to $151,000. Right, so that's a big benefit right out of the gate. I think there's a very high demand for STEM skills in society. I think you're likely to find that you will have more job opportunities than someone that's not in a STEM related field. And I think there's a few reasons for that, right? I think the world that we live in, it's changing, and I think we need people with STEM education to provide solutions to the problems in today's world. And I think as technology continues to develop, to me, it makes sense that STEM fields are some of the fastest growing in the United States and the world. So I guess the bottom line is that not only will you earn a pretty good salary, but you're also more likely to find good employment right out of the gate, right after you graduate. So another one there is job satisfaction. I think employees who enjoy their jobs, they're much more likely to be productive and successful. And I would say that STEM majors, they consistently report some of the highest levels of job satisfaction. And I think working in a STEM job, it's exciting. If you really think about it, all the cool things that we love today, they're the result of the innovative and creative thinking of countless STEM workers. So I think flexibility is another one here that I wanted to touch on. Some degrees, I think, tend to limit students to only a few jobs, kind of pigeonhole them into what they can do. But I think STEM majors, they really have a lot more flexibility. And I would say, for example, an engineering student, they can pursue a career path in a number of different directions. You could go into chemical engineering, computer science. You could get into an environmental related field, science. So a whole bunch of different things that you can get into. And I think it's just that STEM skills, they're in demand for a wide variety of jobs. So it's much easier for STEM majors to switch careers if they needed to, or if they desired to do that. So what I've got there, bottom line is that if you want a job that's high paying, fast growing, and satisfying, a STEM major is a very solid choice. So if you wanted to get into mechanical engineering, there's a whole a wide number of different fields that you could get into. I've got just a few of them listed here, but if you think about it, mechanical engineering, it's really one of the broadest career disciplines that you could consider getting into. So I think if you do get into mechanical engineering, you'll have a lot of choices. You should certainly be able to find something that interests you. Like I said, I've just got a few of them listed here, such as aerospace, automotive, construction, chemical, energy, defense, medicine, robotics, sales. And the one that I'm in is pulp and paper. So lots of options, and I certainly think you'd be able to find something that interests you. So what advice would I have for students that are pursuing a career in STEM? I think there's a few things that I would touch on. And the first is learn by getting real world experience. I mentioned that I had a couple of co-ops when I was in college. So I would say use your summers wisely. Get an internship if you can. These are typically 3 months long. Another alternative would be doing the co-ops that I took. So several universities, they offer those programs. So you'd be working typically for a summer plus 1 semester of school. And those are typically paid as well. So it's a great way for you to offset some of the costs that come along with school. And the experience looks really good on a resume too. So my experience was it allowed me to take a break from classes and earn some money and then gain real world experience so you can hit the ground running when you're hired for your first full-time job. So like I said, I had 2 co-ops when I was going through college, and I think both of those were really outstanding opportunities for me to learn on the job, gain valuable experience. And I truly believe, I think that helped me get my first job right out of college. So second thing that I've got listed there is find a mentor. I'd recommend that. Find somebody that you can get really good direction from that's working in a field that you're interested in. So these could be people in your community, it could be in your church, a neighbor, a parent of a good friend. And just get with those individuals and job shadow them if you can. Ask them a bunch of questions. They're great resources. Take your time researching degrees in industries that you're interested in. There's so much information out there that you can lean on and dig into. So I'd recommend going to the library, just using the internet to learn as much as you can about the different areas that you're interested in. Always be curious, always be willing to learn and to ask lots of questions. I think one of the things that I see is a lot of engineers that get out of school and they can be a little hesitant to ask questions because they're afraid that they'll look bad. But I would encourage you to lean on others to help you because you're going to learn all kinds of things on the job that they don't teach you in school. So definitely don't be afraid to ask questions. When you're in college, I would encourage you to just to realize that there will be some difficulties along the way, right? I mean, I think most people realize that engineering, it can be one of the tougher degrees, and the courses that come along with that can be difficult. So you do have to be dedicated. You got to be willing to work hard, and I don't think there's really a substitute for that. But just persevere, keep at it, don't give up. You'll get there. There was a lot of times during college when I did want to give up, but I persevered. I pushed through the challenges, and I'm very, very glad that I did do that. So, and yeah, just engineering classes, they can be tough, and they might not be what you thought they would be, but I can promise you it'll pay off. It'll be worth it. And when you think about it, the 4 years that you're in school, it's a relatively short period of time in comparison to a 40-year career. So once you graduate, like I mentioned earlier, you'll be able to find something that you like to do. So So just when you're in college, don't be afraid to ask for help. Use your resources, go to your professor's office hours, join study groups, help each other out with your classes, get a tutor, things like that. So, and the last one is kind of a side note. It's totally unrelated to academics, but I would encourage you all to learn a little bit about personal finance. And it might sound a little bit silly, but learn how the stock market works, learn how to invest in a 401k, a Roth IRA, learn what a mortgage is, and then use the money wisely. When you graduate, you're going to have a pretty good job and you'll start earning good money. And I would encourage you to start investing some of that money right away. I see a lot of people, they start and they usually one of the first things they do is they'll go out and buy a brand new car. And I would encourage you to try to avoid doing that if you can. I'd say don't go out and just blow it on a new car right away. And me being a car guy, I love cars as much as anybody, but I think there's an opportunity cost if you go and do that and buy the car and don't start investing right away. So start looking into that, start setting money aside once you are making money from your first full-time job, and just get educated on real world financing. And I think you'll really thank yourself later in life if you do that. So that was what I had for my presentation. Are there any questions?
I guess I can start us off with a question. So, does mechanical engineering, I know there are a lot of different fields within mechanical engineering, but do most of them generally need to have like good computer skills or coding skills to do well in the fields these days?
I would say in my role that has not been the case. And I would say in general that's probably not the case. I took maybe one or two programming classes that I can recall when I was in college, and I have not used them in my role at all really today, as far as the programming and coding side of things goes. So for me, that I could see in some other roles, um, possibly in engineering, where that might be the case, but for me, it has not been.
Another thing I was curious about is that you mentioned you had you got a minor in mathematics when you were getting your bachelor's degree, and I was kind of curious how much math plays a role in it. I mean, I know obviously like with engineering you need math, but like in your job, like do you use a lot of math still today, and like is it very high level math? So yeah, I was just kind of curious about that.
Yeah, it's a good question. The reason I had gone for the minor in math is it was really, I think it was only, I want to say like 3 additional classes, because there was so much math to get the engineering degree. So it was only a few extra classes to actually get the minor. So I said, well, I'll just incorporate that and just take a few extra courses for a few extra semesters, and I did it that way. I would say for the most part, it is still the stuff that I use on a day-to-day basis is pretty high level. For my role, at least, we typically aren't getting into all the calculus or linear algebra or the differential equations, things like that, on a day-to-day basis. And it's more of the basic algebra and arithmetic type math that I'm using on a day-to-day basis. So that is, I guess, as far as the math side goes, I do use a lot of the technical classes on a day-to-day basis, more like fluids and thermodynamics, things like that, but maybe not as much on the math side.
All right, and I think we have time for one more last question. And so I received a question, like how have your job responsibilities changed between when you first went in as an entry level worker between and now as like a project manager?
Mhm. Yeah, so that's a great question. Like I said, when I first started, my some of my very first projects that I was managing back in 2013, I think they were between like $30 and $50,000. As far as capital projects go here at the mill, those are fairly small. We've got some projects that make it into the capital plan, and they're upwards of. I think we just completed one that was about between 30 and $40 million. So um, I would say as I have gotten more experienced, I was given larger opportunities. And as I successfully implemented projects and had started to develop that track record, I was given more and more responsibility to manage larger projects. And when I first started, I would say I was a project engineer, and I would be working underneath another project manager more often than not, kind of learning the ropes, learning how the mill worked, what our processes were here. And as I developed those skills and got more comfortable um, with the engineering side of things, I was given more, and then I started managing those projects. And just kind of over the years, they've gotten larger and larger. These eventually got over like 100,000, then 500,000, and then a million, and now like I said, they're over $10 million. So it wouldn't surprise me if there's more larger projects coming down the road eventually. So it's been neat to see that progression, and now I'm kind of the one that's more managing managing the projects in general. And so I've got a team of project engineers that would typically work with me to develop those projects, and so that's been fun to see that progress.
Okay, so I think that'll be our last question. Thank you so much, Mr. Hilden, for your presentation and your answers. It was definitely very interesting to see, I guess, a different kind of industry and how mechanical engineering can be used there. So thank you so much to Ms. Schneider and Mr. Hilden. If anyone you know couldn't make it this time, we will be posting an update to our mailing list and Instagram once we have a recording uploaded on YouTube. We've also posted our last seminar's recording to our YouTube account as well at CSTEM US. And you can see those in the chat.
Yeah, so this will be the conclusion of our seminar. Once again, thank you to our guest speakers, Ms. Schneider and Mr. Hilden, for their amazing presentations. And this is definitely one of the kind of different spin on careers that we haven't seen before. So I'm really excited that we got to have this opportunity. And so as Annika mentioned, we've posted the survey for this seminar and also recordings for the previous seminars in the chat. So be sure to take a look. Otherwise, thank you everyone for attending today, and have a great afternoon.